In this series of videos, we're going to assemble an MSAI 8080 MPU-A printed circuit board. This is a reproduction card. It reproduces the original MPU-A card from back in the day. I have a new old stock MPU-A card as part of an assembled kit I own. And so this board was based on that board. Schematic capture was done. Printed circuit board layout was done to be pretty identical to the original board, and we've been through a couple engineering revisions, and at this point, I'm ready to assemble another card, and I thought I'd share that assembly process with you. So with that all said, let's dive in. So I want to welcome you to the video. In this video, we're going to assemble an MSAI 8080 MPU-A board. The board right here, this board houses the 8080 processor for the MSAI and all the interface logic that makes the system work. On the bench here, we have an original board. So this is an original new old stock board from 1975, 1976. It's never been assembled. This board comes out of my collection. And this is the board we base the reproduction on. We, of course, have the reproduction board here. This is still an engineering sample, the reproduction board. Your board will be slightly different from this. Electrically, it'll be identical. The component layout will be the same, but there's some details in the circuit board that are a little bit different to make it more accurate to the original board. So again, your board will look a little different from this. If you look close, you may not even notice the difference. Like I said, this is an engineering board. We have the original manual here. This comes out of an original MSAI 8080 user manual. I have two of these. Both the manuals are about the same shape. The paper is yellowed. It's stained a little bit. It's just kind of, there's stains here. It's just kind of dirty. It's very readable and very usable. But one of the things I wanted to do in this project was clean this documentation up and make it more like it would have been if, when you originally bought your kit. And that's what this sheet right here is. And I've been working from this sheet, so it's a bit folded and stapled and stuff. But it's pretty good representation of what the final sheet will look like. So I have gone through and scanned that original documentation and then did a whole lot of processing and editing to clean it up and get it nice and bright white and looking more like I believe the original would have back in the day. So we'll be using the steps in this manual to assemble the board. We also have here a sheet that will be included in your kit, and that's this component location sheet. What have I got on the paper there? No idea. It's a crease in the paper. The sheet that is the component location for assembly. This makes the board a little bit easier to assemble. You don't have to use this. You can do everything based on what's in the manual here and referring back to this drawing as best you can for component locations. It can be a little bit tough because you may notice on this sheet nothing's actually marked for the discrete values. The discrete components where they go. The logic components are of course called out. A1 is here, A2 is here, A3 is here. Those numbers exist in the board in the metal mask, and because this board here in the photograph isn't solder masked, those pop out. On an actual board that's solder masked, they're much more subtle here, but the same markings are there, and the same markings, of course, are here on the original board. So I will be using the parts placement diagram. It makes this a little bit easier to do. So let's jump in here and find these step-by-step assembly instructions, which are sitting right here, and give these a shot. So I have gone ahead and pre-bent, the resistor leads. Just to make the assembly go quicker, you don't have to sit and watch me bend resistor leads. And that's actually a good segue to tools. I use a lead forming tool, so I can take a resistor, I can drop it down into the tool, and I can fold the leads over to get nice square shoulders and get the parts centered pretty well between the bends. All the resistors on this board are on 1/2-inch centers or 0.5-inch centers, except for the one power resistor, the 470 ohm, that's on 0.6, and that's accurate to the original board. So using this tool, like I said, I pre-bend all the leads. So let's jump in. There's 19 1K ohm resistors. Let me get the 4.7K out of the way. Here's the pile of 1K. And it wants to install and solder 19 1K ohm resistors, R1 to R13. So we've got, let's see, well, let's just work from the corner up. So R1 to R13, R15 through 17, and R19, 20, and 21. So R1 through 13 will catch what's down here. So there's 5, 6, 7, 8, 9, 10, 11, and 12. So we know these 8 down here are 1K, and in the parts placement diagram, I've indicated the value. So we can just go ahead and drop those onto the board. I choose to put resistors in so the tolerance band faces the same direction. In this case, to the bottom of the board, or to typically the right of the board. So I will put all 8 of these in. With the, like I say, the gold tolerance band here down. Your resistors, of course, may look different from these, but they will be marked brown, black, red, or 1K ohm. Yeah, pretty exciting here watching me stuff the board, I know. And my centering alignment here isn't perfect. That's fine. If you were hand bending these leads, it would be even less. And of course, you can hand bend the leads and get a perfectly acceptable result. I just tend to like things a little tidier myself if I can get it tidier. So that installs all of them. I'm going to flare the leads out a bit here to hold the resistors in place. You may choose to use blue painter's tape. I tend to use it also to hold components on, and at least for these resistors, I'm not going to do that. And we'll get some normal solder here. I believe this is 6040, or it might be 6337, but it's just normal rosin core solder, like you'd use for any electronics project. Be sure that you use the correct solder. You don't want to use plumbing solder here because it will destroy the board. So I'm going to do my best to keep my head out of the shot here, which makes this soldering harder for me because I can't see as well. I'm used to working much closer to the board. Yeah, most exciting thing on the planet here, soldering. You may have just heard Murphy, my 80-pound German Shepherd, pop up and run from the room. He likes to hang out here in the shop with me while I work. He's a very good boy. He just is. He was a adoption from a local shelter. Had kind of a rough life previous to moving here with me. He was taken well care of and loved, but just due to some circumstances, the previous couple of owners just couldn't keep him. You know, it just is kind of the reality. But he's here with me and hopefully will be for as long as I'm able to solder. Like I said, can't see as well as I'd like to because I'm trying to stay with the camera. I use a pair of Knick picks, K-N-I-P-E-X, flush cutters. These work really well. They're a very nice tool. I've got a whole bunch of cheap ones, you know, the $3 for $5 stuff you can get out there on the market, and those wear out pretty quick, and I tend to destroy them. This pair I've had for several years, and they just cut still fantastic. I haven't actually abused these like I tend to do the cheap ones, so I'm not cutting, you know, heavy gauge wire and that kind of stuff with them. Boy, that lead is just positioned so I can't get to it. Let's turn this up where I can actually see what I'm doing. Of course, I'm wearing glasses here so that a lead doesn't come flying off and poke me in the eye. Having had cut leads bounce off the glasses, I definitely recommend that. So we have taken care of these. Whether you want to mark your sheet up or not, it's really up to you. we move on to the 4.7K. Install the 10 4.7K resistors at R14, 18, etc. I just happen to know that 8 of them sit up here. These guys right here. Let me get these in here where I can get at them. So I've been running a couple of these boards that were assembled, the original version, so the original layout. I've been running those for literally weeks and weeks, if not months, continuously doing system tests like RAM tests and running CPM and that kind of stuff. And I've had them, consistently running just to try to wring out any reliability issues. Part of that work is qualification of vendors for new old stock parts. These parts are getting harder and harder to find. The CPU, the clock generator, the bus drivers, all those parts are really obsolete and they're hard to source. And we're trying to strictly work with new old stock parts wherever we can get them. But I still do a qualification, kind of a burn-in qualification run with each vendor that we are finding that we can get parts from. Getting parts where the vendor has sufficient quantity and can supply, out of that quantity over a period of time is a little bit tricky. But we'd really rather have your board come up and operate after assembly than have to chase a bad CPU chip or a bad clock chip or whatever. We'd just like the board to work. I don't know how many original abandoned builds there were of IMSAI's back in the day. I know there was at least one, because I have the CPA, the front panel, out of that machine, picked it up on eBay. It was very obviously an abandoned build. I have repaired that board and then actually stripped that board down to replace all the sockets because there was so much corrosion down in the sockets. And that's been a fantastically, it runs really well. It's a fantastic piece to have in my collection. And have it fully working is really nice. It's a great reference. I may have mentioned this as I kind of introduced the video series here. I have a new old stock MSI 8080 kit with an entire original case that's never been assembled. All of the components, it's the CPA board, the MPU-A board, the board we have here. It's the 28 amp power supply board, the PS, it's the PS28 or PS-28. All the hardware, LEDs, like I say, all the electronics. The one board it didn't have was a RAM board, like the RAM 4A, something like that. And because the 2102 chips are super hard to find anymore, that the RAM 4A board uses, I've not completed cloning that board, because if you can't get the chips, the board doesn't do you a whole lot of good. So there's a 4.7K there. And I put those off to the right. Spun at 180. So we're working on some alternatives for RAM cards for your system. Stay tuned. There'll be more to come. And there's a 4.7K I was going to say right there. So really pretty simple initial part of the build, following their instructions. Resistors, let's get these two soldered up. And then we'll hit the 1 power resistor here. So these are all 1/4 watt resistors, which is what's spec'd. There's a resistor on the board that's part of a Zener voltage regulator. It produces the -5 volt rail that the 8080 requires. And it's using a Zener diode regulator. And Zener regulators, if there's 8 volts coming in and -5 going out, or -8 coming in and -5 going out, those other 3 volts have to be gotten rid of, and they get dissipated as heat. So there's a 470 ohm 1/2 watt resistor in your kit. It'll, physically, most likely be physically larger. This may actually be bigger than a 1/2 watt, but it's the one I'm going to use. There's a space up here on the board where it goes, which is, why aren't I seeing it here? We just found a little issue in the documentation, which I will fix. The 470 1/2 watt is mounted here. I've looked at this 100 times. I can't believe I've still missed something. So because it's a power resistor, they tend to dissipate more heat. And circuit boards you may have seen or repaired, you'll often see a burn spot on the board and there'll be a large resistor sitting next to it. One of the things you want to do with power resistors is you don't want it down tight flush to the board. You want it up off the board a little bit, because that increases the airflow around it and helps protect the actual PC board itself from the resistor. I probably have that a little higher than it needs to be, but there'll be plenty of clearance on the board. So yeah, mount power resistors a little proud of the board like I've done here. It's just a little bit more of a quality build. So the second thing to note here is this lead I'm over here has got a large copper pore there, and there's no thermal relief here, which means this can be a tricky spot to get a good solder flow on. Also, the resistor leads are larger, so be patient here when you solder this. It may take several seconds to actually get a good solder connection. Looks like I got a good solder connection, and that's just the way they designed the board. More modern boards have what's called a thermal relief that isolates a bit the solder pad from the large copper area. Ow, that lead's still very warm. So appreciate you watching the video. I hope this was informative and helps you with your build. If you've not subscribed to the channel, I encourage you to if you think it's useful. A like is always useful as well. In the next video, we'll continue the assembly of the MPU-A board. I hope to see you then.